Okay, this is the P3 paper from June 2024. It's question number 8, and as you can see, this is quite a long question here. We've got some exponentials and logs. We're going to be doing exponential modeling using that function. Down here, when we're trying to find the maximum value, we're going to be differentiating. We'll be differentiating exponentials. We'll be using the chain rule, we'll be using the product rule, and then at the very end, we've got some numerical methods there with some fixed point iteration. So really big question, lots of different parts to it. We'll just take each part separately as we read through it, but it basically says this H is the height of a golf ball. So the height of a golf ball is being modeled by this equation here. And then the first thing it tells me is, can we see if we can find the value of D? And the value of D is going to be when H equals 0. So I can do that bit without reading through the rest of the question, and I am going to make a start to it. It's going to be quite a long video here. So for part A, let's make it clear to the examiner what we're saying. We know that H is given by this complicated function here, 1.5x minus 0.5x e to the 0.02x, and they don't apologise for the complicated nature of that function. It's all part of it. It's a question 8. Should be relatively difficult. D is going to be when H equals 0. So let's just say that at D, H is equal to 0. So we're going to get 1.5x minus the rest of this function is going to be equal to 0. So if I look at this function, I can take x as a factor out. We could have seen that from the graph, which showed me x equals 0 minus 0.5 e to the 0.02x equals 0. So I'll either get x equals 0, which is say we could see off the graph, or the other one is going to come from 1.5 minus 0.5 e to the 0.02x equals 0. So it's relatively straightforward rearranging here, just not very nice numbers to be working with. We're going to say 1.5 is equal to 0.5 e to the 0.02x. Divide both sides by 0.5, so we're going to get 3 equals e to the 0.02x. Then how do we get rid of that x there? We can log both sides, can't we, to get rid of the e? So natural log both sides gives me 0.02x is equal to that, which means that x will be log 3 divided by 0.02, and they wanted the answer to 2 decimal places, and to 2 decimal places x, or I guess d rather, works out to be equal to 54.93. Okay, there were the two possibilities, x equals 0 or x equals that value that we've just worked out. So part A, working out the value of D, done. Part B then says show that the maximum value of H occurs when x is equal to this thing here. Well, I won't panic too much about getting that. What I will do is work out what my method's going to be. And if I want maximum value, what I'm going to do is differentiate and then put dh by dx equals 0. But differentiating in the first place is going to take a little bit of time here with this one. So part B, we've got that h equals 1.5x minus, and then this horrible term that we keep talking about, 0.5x e to the 0.02x. So when I'm differentiating, that's going to be no problem. That's going to be 1.5. But differentiating the other part, we can see we have a product there, 0.5x times e to the 0.02x. So I'm just going to focus on differentiating that bit there. So the differential, you don't need to write it like this, I'm just for explaining it to you guys. The differential of this bit here then, I'm going to do this as a product. So I'm going to say u equals 0.5x, v equals 0.02. No, it doesn't. It equals, let's get that right, e to the 0.02x. So du by dx, straightforward, is 0.5. dv by dx, hopefully you can do this and think about what the differential of e to the 2x is. The differential of e to the 2x is 2e to the 2x. It's the differential of this multiplied by e to the 2x. So following exactly the same argument through there, this is going to be 0.02 e to the 0.02x. So then we get that the differential is going to be equal to u dv by dx plus v du by dx. That's the way I do my products, using that formula there. So u dv, those two, v du, those two. That's why I set it all up like this. It's easier for me to remember that way. You might have your own way of doing it, as long as you end up with the same answer. So u dv dx is 0.5x times 0.02 e to the 0.02x. Really takes a little bit of concentrating as you're going through doing this work. The other two, 0.5 e to the 0.02x. Now remember, I'm only differentiating here this part. So if I now want to say what dh by dx is, dh by dx is actually differentiating 1.5x as well. So it's 1.5 minus, and then everything that we've got in there, which is, let's have this as 0.5x times 0.02 e to the 0.02x plus 0.5 e to 0.02x. So that's the differential. Then the maximum is going to be, sorry, something's happening to my pen. Let's try and get sorted out. Maximum is going to be when dh by dx works out to be equal to 0. So I want all this thing to be equal to 0. So if I want all of that to be equal to 0, so now let's go about starting to tidy this all up. So I'm going to say it's 1.5 will equal, now let's tidy this thing up. I can take 0.5 e to the 0.02x out, 0.5 e to the 0.02x out as a factor. And what will that leave me? Something slightly neater now, 0.02x plus 1 in there if I tidied that all up. So once I've got to that stage, I can then say that e to the 0.02x then is going to be equal to 1.5 all divided by 0.5 0.02x plus 1. Well, the 1.5 and the 0.5 we can tidy up. That's just going to be 3, isn't it? So I'm going to get e to the 0.02x is equal to 3 over 0.02x plus 1. And then I just don't want 0.02x in there anymore. So how am I going to get rid of that? If I times everything by 50, top and bottom, so I'm just going to times the top by 50 and the bottom by 50, I'm going to do that. What that will do is it will just get rid of the decimal, the 0.02. So I'm going to get, can't do it on this side, this stays as e to the 0.02x, but on the other side, timesing everything by 50 will give me 150 over there is equal to x, 0.02 times 50 is that, plus 50 lots of 1 plus 50. So we're beginning to get closer now to what we want. Just like previously, I'll log both sides here. So I'll get 0.02x is equal to log 150 over x plus 50. Now, I haven't been keeping an eye on what you were trying to do, but you might have kept at some stage, where are we, going back to that to see how close am I getting to what I'm trying to show for my answer here. But I wouldn't be too worried about it as I was going through and doing it. So here, again, if we multiply everything by 50 to get rid of that 0.02 again, we'll get 50 log 150 over x plus 50. So not nice algebra at all. I appreciate the fact that that's not the simplest of algebra to be doing, but as I say, it's part of the deal when we've got an exponential modelling that we might have some nasty algebra to work with. Okay, once we've done that part then, part C says if this is the iterative formula now, this one here is the iterative formula, and we know we're going to be starting off with x1 equals 30. Can we find x2? Yeah, that'll be really, really straightforward. And then if we repeat the iteration, can we find x to 2 decimal places? So what I will need to do is keep going with my iteration until up to 2 decimal places it stops changing. And so I've done this before. It takes a lot of iterations to get to that, but we'll talk about that part in a second. Part C, it said that my iterative formula is x to the n plus 1 is given by 50 log 150 over x to the n plus 50, and it tells me that x1 is equal to 30, it says, and it wants me to work out x2. So x2 is 50 log 150 over, and we put x1 in now, don't we? So over 30 plus 50 here, which is 50 log 150 over 80. 150 over 80. And then I don't need to worry too much because it says, can I do it to 2 decimal places? So yeah, to 2 decimal places, x2 will work out to be equal to 31.43. Once I've done that, then it says, right, now can I show it to 2 decimal places, which means I need to find x3, x4, x5, and so on. So x3, which would be a matter of putting x2 in, I'm just going to tell you to 3 decimal places what these answers work out to be, and it works out to be 30.544. x4 works out to be 31.091. So obviously I've done all this previously. x5 works out to be 30.753, and so on and so on. I'm not going to go through all of them because there's loads to actually get through here, and it goes 30.962, 0.833, 0.913, 863, 894. But eventually what it does is it starts settling down as the last few that I get is it works out to be 30.884, 30.881, 30.883, and at that point I can say, right, that's settling down now to 2 decimal places. That's 30.88. So once it stops oscillating and stays 30.88 and the change of decimals is into the 3rd, 4th, 6th decimal places, then we can say, right, I'm happy up to that point that it works out to be 30.88, which is what is the final answer. Okay, good long question there, lots of different parts to it, but really useful in terms of our revision process to make sure we're okay with that one. Hopefully that all makes sense to everybody.